Ever wondered how we can find the value of a function at a point where it seems to break? Today we're diving into a powerful calculus concept, limits. We'll tackle a classic example, finding the limit of the function x squared minus x minus 6, all divided by x minus 3, as x approaches 3. First, the simplest step, direct substitution. Let's plug in x equals 3 into our expression. This gives us 0 divided by 0. This is an indeterminate form. It's like a mathematical riddle. It doesn't tell us the answer directly, but it tells us we need to do more work. Our next move is to simplify the expression. The key here is to factor the numerator. We're looking for two numbers that multiply to -6 and add to -1. Those numbers are -3 and +2. So x squared minus x minus 6 factors into x minus 3 times x plus 2. Now we substitute this factored form back into our original limit expression. Notice something amazing? We have x minus 3 in both the numerator and the denominator. Since we're taking the limit as x approaches 3, but not at x equals 3, we can cancel these common terms. This leaves us with a much simpler expression, the limit of x plus 2 as x approaches 3. Now, with the problematic part removed, we can finally use direct substitution. Plugging in x equals 3 gives us 3 plus 2, which equals 5. And there you have it. The limit of our original function as x approaches 3 is 5. This means that even though the function had a hole at x equals 3, the value it approaches from both sides is 5.